Alright, so we are going to solve some logarithmic functions today, or exponential functions. Alright, so one way to solve exponential equations is to make the bases on each side match. If you can make the bases match, then you can write an equation that says the exponents have to be equivalent. Otherwise, this wouldn't be true. So you rewrite the equation, make the bases match, and then write your equation m equals n, solve for the variable. Alright, but what does this all mean? Well, do you remember back in the days when you'd get in a swimming pool and you'd have chicken fights where you get on your friend's shoulders, right? You want the two guys on the bottom to be matched so that the two guys on top can fight. Those are actually my cousin's twin sons. Anyway, yeah, it's like a chicken fight. Okay? I'm supposed to play music. Anyway. Alright, so here we go. Here's an example. We want to make the bases match, set exponents equal to each other, and solve for x. You can try to take the small one and divide the big one. So by 9 would be 3. That's not going to work. I need all 9s or all 3s or all something. So I can't break 27 down by 9. I obviously can't break 9 down by 27. So what can I break them each down by? 3s. Remember our good old prime numbers when you're first starting to break numbers down and I said only use your primes? Kind of same thing here. So if I break 27 down by 3 would be 9, by 3 would be 3. So 27 I can rewrite as 3 cubed. 9 I can rewrite as 3 squared. Now my bases match, but I've got to power my power. When you power power, you multiply exponents. So this is going to be 3 to the 3 times x plus 3. And on this side, this is going to be 3 to the 2 times x minus 1. And now, since my bases match, then these two, the exponents have to be equal as well. So 3 times x plus 3 has to be equivalent to 2 times x minus 1. It has to by the definition. So now if I solve what's left, distribute, I have 3x plus 9 equals 2x minus 2. Get x alone, minus 2x, I have x plus 9 equals negative 2, minus 9, x equals negative 11. And you're done. And you can check it. If I do 27 to the negative 11 plus 3 equals 9 to the negative 11 minus 1, that would be 27 to the negative 8th equals 9 to the negative 12th. If you type in 27 caret negative 8, you get 3.54 e negative 12. And if you type 9 caret negative 12, you get 3.54 e negative 12. They're worth the same amount. You don't have to check it, but you can. Alright. So let's try this one, okay? I can't break down 2 anymore. So that means I have to be able to break 16 down by 2s. And what happens if you can't? If you can't, then we learn another method to solve. But for today, you'll be able to make the bases match. If not, like I said, I'll teach you another technique in a couple days. So if I break 16 down by 2s, by 2 is 8, by 2 is 4, by 2 is 2. So I have 2 to the 3x minus 8 equals... And I can rewrite 16 as 2 to the 4th. So now my bases match, which means my exponents have to be equivalent to each other. So I can write an equation, 3x minus 8 has to equal 4. So to solve, I'm going to add 8. Add 8, I get 3x equals 12. Divide by 3, I get x equals 4. Alright? So hit pause. You try this one. Come back when you're ready. And hopefully you got 2. I need to break 8 down by 2's. So by 2 is 4, by 2 is 2. So I have 2 to the 1 plus 2x equals 2 to the third. These match, so now my exponents have to be equivalent. So if I set that equation up, 1 plus 2x equals 3. And I solve it for x, minus 1, 2x equals 2, divide by 2, divide by 2, x equals 1. Pretty easy breezy, eh? Alright, on this one, again, you could try and break 729 down by 81s, but if I did 729 divided by 81, I get 9. That isn't going to work. I need all 81s or it ain't going to work, which means I should probably break it down by 9s. Okay, so if I break 729 down by 9, 729 divided by 9 is 81, divided by 9 is 9. 81, break it down by 9s is 9. So let's see, over here, I can rewrite 729 as 9 cubed, and 81 I can rewrite as 9 squared. Power my power, that gives me 9 to the 3x equals 9 squared. My bases are now equal, so my exponents have to be. So I can claim 3x equals 2, divide by 3, and x equals 2/3. I got it? And actually, you could check this one pretty easily. Type in 729 caret parentheses 2 divided by 3, and you will get 81. Alrighty. Oh look, you can check it graphically. If you notice, I typed in 729 to the x for y1, 81 for y2. Set my window. I kept x's the 10s and I went all the way up to 100 and counted by 10s on y. And if you calculate the intersection, they intersect at 0.666 repeating, which is 2/3, and 81. Yeah? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 3. Alright, I don't think I can break that down by 125s. I guess I could try. 3, 125 by 125. It's 25. I can't. So I can, 25s ain't going to work, but I know 5's going to both of those, so I'm going to start breaking it down by 5. So 3125 divided by 5, 625 divided by 5 is 125, divided by 5 is 25, divided by 5 is 5. If I break 125 down, by 5 is 25, by 5 is 5. So I can rewrite 3125 as 5 to the 1, 2, 3, 4, 5th, and I can rewrite 125 as 5 cubed. Power the power, that's 5 to the 5x equals 5 cubed. The bases now match, so the exponents have to be equivalent. So I can say 5x has to equal 3, divide by 5, and x equals 3/5. Okay, they're going to get a little bit trickier and they're a little harder to read. Okay, this is 9 to the x minus 3 over 8. You need to get out, the bases match except for this one's under a radical. To get out of a radical, remember it's the 9 to the 1 over 2. And now my bases match, so my exponents have to be equivalent. So if I set up my equation and say x minus 3 over 8 has to equal 1/2, because it's a proportion, I can cross multiply. So that'd be x minus 3 times 2 equals 8 times 1. Distribute 2x minus 6 equals 8. Add 6. 2x equals 14. Divide by 2 and x equals 7. Graphically, You see how I typed 9 to the x? Do you see how I had to put my parentheses around the parentheses that were already there? Okay, and y2 I typed in the square root of 9. Set my window to a standard window. Graphed, and they intersect at x equals 7. Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got 3. This is 3 to the x minus 2 over 2. This is 3 to the 1/2. So since my bases are equal, then x minus 2 over 2 has to equal 1/2. Cross multiply and divide. This way is going to be x minus 2 times 2 equals 2 times 1. 2x minus 4 equals 2. Distribute. Add 4. 2x equals 6. Divide by 2. X equals 3. Done. Alright, this one, little tricky. I'm going to rewrite 16 with 2's. By 2 is 8, by 2 is 4, by 2 is 2. So I'm going to rewrite 16 as 2 to the 4th. Now, they match, but this one's on the bottom and this one's on top. Well, you can move it up if you change the sign of the exponent. So this would become 2 to the negative 4th equals 2 to the 3x plus 5. And now that my bases are equal, my exponents have to be equivalent. They don't have to look the same, but they have to be equivalent. So I set up the equation 3x plus 5 has to equal negative 4 minus 5. 3x equals negative 9. Divide by 3. X equals negative 3. Okay. Then we just do that one. Alright, you try this one, hit pause, come back when you're ready, and hopefully you got 4. Alright, I need to either rewrite this with 4's or break them both down by 2's. So I'm going to try by 4 first. So 256. By 4 is 64. By 4 again is 16. By 4 again is 4. So I can rewrite 256 as 4 to the 4th. Get it out of the denominator, change the sign of the exponent, so this would be 4 to the negative 4th. And now my bases are equal, so my exponents have to be equivalent. So I can set up the equation 3x plus 5 has to equal negative 4. Minus 5 minus 5, 3x equals negative 9, divide by 3, divide by 3, x equals negative 3. Okay? Alright, again, only difference here is you have a base e. You still need to make a match, which they do, but he's in the bottom. So move him up, change his sign of his exponents. So e to the x plus 9 equals e to the negative 5. Now my bases match, so my exponents have to be equivalent. So I can say x plus 9 equals negative 5 minus 9 minus 9, x equals negative, or e equals, I should say, no, x equals negative 14. Sorry, he's the number. If I check it graphically, see how I typed in e to the x plus 9 on top and 1 over e to the 5 on bottom? My window, I went from negative 20 to 10 on x. And if you look at negative 14 is where it's equal to e to the negative 5, 1 over e to the negative 5, which is 0.006739.5. But there's my negative 14. Alright, you try this one, hit pause, come back when you're ready. And hopefully you got negative 17. Again, move this guy up. So I have e to the x plus 8 equals e to the negative 9. Exponent, or bases are equal, so exponents have to be equivalent. X plus 8 equals negative 9 minus 8, x equals negative 17. And again, I can break this down by 5s, not square roots of 5, but 125 by 5 is 25, by 5 is 5. I can rewrite 125 as 5 cubed, and I can rewrite the square root of 5 as 5 to the 1/2. So this would be 5 to the 1/2. My bases will match if I power this power and move him up. So I would have 5 to the 3x equals 5 to the negative 1/2. My bases match, so my exponents have to be equivalent. So I can say 3x equals negative 1/2. Divide by 3, divide by 3. X equals, keep, change, flip, negative 1/6. Okay? You try this one, hit pause, come back when you're ready. And hopefully you got negative 1/4. Break 25 down by 5s is 5 squared. Get 5 out of the radical is 5 to the 1/2. Power the power, move the bottom. I have 5 to the 2x equals 5 to the negative 1/2. Set the exponents equal to each other. Divide by 2, divide by 2. X equals, keep the top, change to times, flip the bottom, negative 1/4. Alright, so how do you solve an exponential equation? I don't know why I put a star by it. You make the bases match, set exponents equal, and solve. Alright, we are at homework, so we are done. Happy homeworking, and I will see you next time.